This is a kitchen scale that doesn't quite work. Let's explore. So this is how it looks inside. Not much here. For sensors, I will draw a schematic of how they are connected because it's actually pretty interesting. A PCB, two PCBs with buttons. This is the main PCB, batteries, and that's all. So let's actually unscrew this board and see what's on the other side. So what do we have here? Here's an LCD. This is a backlight for the LCD. This is a board, just some blob. Connectors, I will show you how it's connected in a moment. Yeah, I think I will just draw it and show it to you. Alright, so here's the connection diagram. This is a left bottom cell, left top cell, right bottom cell, right top cell, black wire, red wire, white wire. Well, maybe it doesn't make much sense. Actually, this is how it's connected on the board. First I will show you how those sensors actually work and then draw a better schematic to show you how it actually works, because this is more like a wiring diagram. Okay, this is one of those sensors. You can see it's between white wire and black wire. It's around 1K. When I press it, nothing really changes much. But let's connect, for example, between the ohmmeter between the red wire and the white wire. So now it's half of that, so 500 ohms. When I press it, it decreases somehow. I have to press it really hard. Yeah, decreases very slightly, but you can see that it really decreases. Let's connect now between the red wire and the black wire. Come on. And again, it's around 500. When I press it, you can see that increases. It's really hard to press because those changes are really tiny. But yeah, well, maybe I can redraw the schematic now to make it more clear what's going on here. Well, I come out with something like that. So this can be thought of a potentiometer or a voltage divider. Red is the common one. Between red and black, when you increase the force on the sensor, this resistance goes up and this resistance goes down. So now let's draw how it's actually connected in here, and maybe it will make more sense. Maybe this drawing makes much more sense. This can be thought really as a bridge. You connect voltage between E plus and E minus. You measure voltage between S plus and S minus, and you have a reading dependent on the temperature, on a wave, not a temperature. I don't know how to explain it better. Maybe I will just find some video on YouTube and show it to you, a fragment or something, because, well, but yeah, it works this way. Actually, instead of posting a video, I decided to just post 2 links in the description, so you can check them out. And by the way, what I wanted to test, well, you saw that the display didn't quite work. I already cleaned it before and it didn't make much difference. I wanted to test if actually there is any voltage on those pins. There is AC here, there should be AC here, in phase or out of phase, or some various waveforms depending on the display type, on how many backplanes it has. But well, my suspicion is that this driver chip has some segments failed, and I wanted to test it. Well, I expect to have the same voltage on those pins if it works. the same DC voltage because of course there is some AC here. We can look at it on the oscilloscope if you're interested actually. Well, it seems that it's fine. Actually there are test points here, but I'm touching those ones. Maybe I shouldn't. You know what, let's connect it to the oscilloscope and see how it looks like. Maybe it will be a little more entertaining. Does it even record? Alright, so here you can see the oscilloscope screen, and let me just connect it to, for example, well, first pin, second pin, and so on. I will connect it to every pin so you can see the waveform. It's actually pretty interesting, but it's no, the trigger doesn't work here. Maybe I will. Set it this way. It's actually pretty interesting. So how many backplanes do we have here? One. I'm starting from the beginning. 1, 2, 3, 4 backplanes, and the rest seems to be segments. 1, 2, 3, 4, 5, 6, no, 7, 8, 9, 10, 11, 38 segments, because 12 times 4 backplanes. So the driver chip is working. Actually, it drives the LCD. So maybe the LCD is failing, and this was just my hand touching the probe. All right. So as always, there's a good news and there's a bad news. The good news is I know what's wrong. The bad news is I won't be able to fix it. Take a look. This is a display. I'm doing my best to be able to show it to you. Those are the contacts on the display. For some reason they are rotten, and just so you see, there are no contacts on this side. So the contacts on the LCD are completely disintegrated. I don't know why, I don't know what happened to them, but this is how it looks like. Poor manufacturing. Okay, it's getting out of focus. I don't know, but you can see yourself. This is the quality of the electronics nowadays. Thanks for watching. And by the way, here's another shot, just so you can see it from a different angle. Yeah. Nice. This is absolutely crazy.